Find the equation of the circle with center minus 1, 0 and radius 4. Here's the circle. The center is called HK. The radius is R. R is 4. The distance of this point to this point is 4 units, as you can see. So, as you saw in the previous video, we just plug everything into this formula. So we have x minus h. Well, h is minus 1, so we have x minus minus 1, that's x plus 1. We have to square this and add it onto y minus k, where k is 0 in this case. And we set this equal to r squared. 4 squared is 16. We can simplify this a little bit, because y minus 0 is just y. So we'll write this as x plus 1 squared plus y squared equals 16. So this is the equation of the circle. Now we want to show that the point minus 1, minus 4 is on the circle. Well, if it's on the circle, it must satisfy the equation of the circle. So let's see. We plug this point into the equation. So we write this out, replacing x with minus 1. We must replace y with minus 4. And if we calculate this, we should get the right hand side, which is 16. Well, minus 1 plus 1 is 0. 0 squared is 0, so we can forget about that. Minus 4 squared is indeed 16. So this tells us that the point minus 1, 4 is on the circle. So let me indicate that on the diagram. Minus 1, minus 4 is this point here. Show that the point 1, 2 is inside the circle. Now if it's inside the circle, it means it will not satisfy this equation. Let's just show that it does not satisfy the equation first. Well, we copy out the equation, replacing x with 1. We replace y with 2. We calculate all of this. 1 plus 1 is 2. 2 squared is 4. And 2 squared is 4, so we get 4 plus 4, which is 8. We notice that 8 is not equal to the right hand side, which tells us that the point 1, 2 is not on the circle, but 8 is actually less than the right hand side. So what does that tell us? To understand the significance of our result, we have to realize that the left hand side of the equation of a circle is the squared distance of a point to the center of the circle. So this comes from Pythagoras. If we take any point, say inside, outside, or on the circle, well, the square of its distance to the center is this thing here. So let's say we have some point xy inside the circle. Well, the center is called hk, and we get the distance of xy to hk. We're just using Pythagoras. We actually covered this in the previous video, where xy was a point on the circle, but if xy happens to be inside the circle, then we can still use Pythagoras, of course, it doesn't matter. The vertical distance here is y minus k. The horizontal distance is x minus h. So, to get the vertical distance, we just subtract the y values. To get the horizontal distance between the point, we subtract the x values. And we will be squaring both of these. And that'll give us the square of this distance. We square these and sum them. We get the square of the hypotenuse. Square of the hypotenuse is the sum of the squares of the other two sides. So here's the sum of the squares of the two short sides. So this is the square distance of a point to the center of a circle. So if this square distance is less than r squared, it tells us that the point is inside the circle. So the square distance that we got for the point 1, 2 is 8. And that's less than the radius squared. So that tells us that the point 1, 2 must be inside the circle. Here is the point 1, 2. So the square of the distance of the point 1, 2 to the center of the circle is actually 8. This distance is 8. This distance squared is 8. The actual distance is root 8. But if we square it, we get 8, which is less than 4 squared, less than 16. So in this square distance formula, xy is the point that we're interested in, and hk is the center of the circle. So now we see that if the square distance, x minus h squared plus y minus k squared, is less than r squared, then the point xy is inside the circle. And that's exactly what happened here. Xy is the point 1, 2, and when we calculated the left-hand side of the equation of a circle formula, we got a value that is less than r squared. Now the other situation is where the square distance of the point to the center of the circle is greater than r squared. When that happens, the point xy is outside the circle. In the last question, we're going to show that the point minus 3, 4 is outside the circle. Well, we could do it by plotting the point on the graph, but we're going to use the equation of the circle. So we have minus 3, 4, and we plug it into the left-hand side of the equation of the circle. So for x, we have minus 3, then the rest of the equation is plus 1 squared plus y. For y we plug in 4. Let's calculate this. We have minus 2 squared is 4, 4 squared is 16, so we get 20. We see that 20 is not equal to the right hand side, so that tells us that the point minus 3, 4 is not on the circle, but also 20 is greater than 16. So we can see that since we get a value that's greater than r squared, it means that the point xy, in this case minus 3, 4, is outside the circle. So it's quite straightforward. We just plug our point into the equation of a circle. If we get a value that's less than the right hand side, it means the point is inside the circle. If we get a value that's greater than the right hand side, than r squared, then the value is outside the circle. And if we get a value that's equal to the right hand side, then the point satisfies the equation of the circle, which means that the point is on the circle. So let's look at minus 3, 4 on the diagram. Here is minus 3 on the x-axis. This point here is minus 3, 4. It's just outside the circle. So its square distance to the center of the circle is greater than 16. Its square distance is actually 20, which means that its distance to the center of the circle is the square root of 20.